Hello, this is a short video to show you how we can use AlphaCell in the field of aeronautics to compute sound absorption or sound transmission loss. But first I would like to recall you some information about the transfer matrix method which is used behind AlphaCell. So if we take a picture of a landscape like the picture on the top of the screen, we have different information on it, and if we want to represent this information with the finite element method, we will end up with a mesh like the one we can see here with different triangles with parameters inside them. So we have the parameters for the sand and the parameters for the rocks, for the first water level, for the second water level, and for the sky, for example. And in the case of the transfer matrix method, we only have a stack of plain layers. So we have information about the sand, but we miss the information about the rocks, and we have also information about the water levels and the sky, of course. So we can see that the transfer matrix method is limited compared to the finite element method, but it has advantages. And one advantage is the fact that it can compute things quickly. So here we have a three-layer system which is supposed to represent some kind of partition of a fuselage of an aircraft with an aluminum plate of thickness 3 mm, a glass wool with a mass density of 8 kg per cubic meter and a thickness of 25 mm, and finally a plastic barrier of a thickness 2.5 mm. And we can compute the sound transmission loss of this system. So on one side we have an anechoic ending, and on the other side we have the excitation, a diffuse sound field. And I click on the button and we get the result of the sound transmission loss for this configuration computed with the transfer matrix method. And it's quite easy and quick to see the influence of one parameter. For example, the influence of the open porosity of the glass wool on the sound transmission loss of the wall system. So here is the second sound transmission loss, which is computed for a lower open porosity for the glass wool. We can of course change the material. So I will replace the glass wool with a melamine foam, and again I will compute the sound transmission loss in this case. Okay, with elastic effects. Okay, we can also add studs or rigid links between the aluminum plates and the plastic barrier. So these are the black lines we can see here. These are links between the two plates. And of course we have another sound transmission loss, and we can see that the difference are only visible at low frequency for this particular configuration. We can also change the excitation for turbulent boundary layer, here with a velocity of 50 meter per second and a boundary layer thickness of 0.1 meter. And of course, so I will clear the screen and we can compute again new results for different kind of configuration of our materials. Finally, I want to show you some trick about materials or system with non-homogeneous thicknesses. We can compute approximation of the sound transmission or sound absorption coefficient with the transfer matrix method. So for example, here we have a material or a system, so a set of layers with different thicknesses on one plane, and we can have an estimation of the sound transmission loss or the sound coefficient absorption by using a composite tool, which is so here on AlphaCell we load the information about the sound transmission or sound absorption for each thickness of the layers we have, and the surface information. So we can see that we can set, for example, a surface of 0.3 square meter of 1 thickness and a surface of 1 square meter of a system with another thickness and air inside it, and it computes the an estimation of the sound transmission loss for this kind of configuration. So thank you for your attention.